chunking. Did Miss Ball let you guys make a catapult and go out to the? If you had me, I did. Never did it. His was one of the best ones ever made because it was small. Well, he kept it. Yeah. These are just ones people say that I can keep. So if they want to take theirs home, I'll let them take it home. But his was really good because it was very small, but yet very powerful. So it was like one of the most efficient ones I have ever had. It might not throw it further than some of them, but the ones that threw it further were much bigger. Yeah. So yeah, it was very efficient though. The way that you like had it set up was different, because yours like pulled the front, the rubber bands on the front pulling down, aren't they? Yeah. I like mixing it up. Yeah.
The rubber bands are at the front, so I pull the arm back.
Yeah. Yeah. Yeah, yours is good. You were the winner, right? Yeah, you were the winner that year. Okay, all right. Okay, so, all right. A pumpkin is launched from a height of 15 feet with initial upward velocity of 60 feet per second. So, in Math 1, I know that Ms. Ball usually does these problems, and I do as well, so you've probably seen it before. This is that basic formula that we use that gives the height of the pumpkin. In Math 1, the only thing you're able to do is the height of the pumpkin. Like, that is the only thing you have the knowledge to be able to do. So you would, for this, you would do h equals negative 16t squared. The v sub 0 is your initial upward velocity, so you put 60 there. And then your height is 15, so you put 15 there. So this equation would give us the height at any point. So if we want to know how high probably quadratic formula. But, all right, so we're going to go beyond what we did in Math 1. Let's get the jar out. Okay. All right. Okay. Possibly. All right. So, the first thing asks us what is the average speed of the pumpkin from 0 to 1. So, I like the plug-in 0, plug-in 1. Let's look at the graph just to see. So this is, we'll call it f of x instead of x. Negative 16 x to the second plus 60x plus 15. Let me hit the, usually there's a home button there too. Okay. Oh, still not far enough. Let's see. Okay, so we got this. There's our height of our pumpkin. You sort of picture it going up, coming back down. So we're wanting to see 0 f of 0 and 1 f of 1. So because if I want to find f of 0, this one, like if I put a line between these two, it would be called a secant line because it touches the line at two places. So f of 0, we would just plug in 0. What would we get? We'd get 15. F of 1, we would plug in 1, so we'd have negative 16 plus 60 plus 15, 59. Yeah. this is not calculus on this part. So, if we want to know the speed, this side right here is our height, and this is our time. So if we did change in the y, which is our height, over change in the x, which is our time, that would give us the speed, right? Average speed. So with the slope formula, so you got 0, 15, and 1, 59. So you'd have 59 minus 15 over 1 minus 0. So we're going to get 44 over 1. So 44 feet per second. Yes?
So now that we know how to find derivatives, now we can answer problems like, what is the speed of this exact motion?
Yes.
So cool.
So, this is like Margaret asked, this is not calculus part 1, right? That's not calculus, that's just slope. I could get my Math 1 students to do it. I don't know if they understand exactly what they were doing, but I could get them to do it, right? I'm not going to try, but I could try. Yeah. Yeah. You know, one time I did have my calculus class help. It wasn't my Math 1 class, it was like Coach Wood's or Miss Ball's Math 1 class. And my calculus kids could not remember how to do some stuff like the Math 1 way. They would like be taking derivatives and try to find critical numbers and all this stuff to like answer questions that they should have done it the Math 1 way for that. So it was kind of fun. All right, so instantaneous velocity at 1. At 1, that is the slope of our tangent line at 1. So if we find our derivative, which is going to be negative 32x, taking the derivative of our original problem. And I really should not be using f of x's, and I should be saying h prime of t equals negative 32t plus 60. So if I want to know the velocity of the pumpkin at t equals 1, I just plug in 1. Negative 32 times 1 plus 60, which is going to give me 28 feet per second. Yes, this is calculus.
Oh, easy.
Yeah. Yes. Because velocity would be our slope, which in this case is our change in y, which is our height, over change in x, which is time. Height over time is going to give you your velocity. There. So this would be our speed at this point. 3 says what was the velocity of the pumpkin when it hit the ground. Okay. At the moment when it hit the ground, how fast was it going? So we want to know. Now, after it hit the ground, it was 0. But at the moment when it hit the ground, not when it stops once it hits the ground, but the speed. So we're thinking like, what if it doesn't hit the ground? What if it hits you in the head? I don't know how fast it's going when it hits me in the head, because if it's going slow, it's not going to hurt that much. If it's going really fast, it's going to hurt a lot more, right? So, it is actually not 4, I don't think. It's 3.985. So, if this was not calculator active, which I'm going to make it calculator active so I don't have this, you would have to do quadratic formula, because it's going to hit the ground. You'd have 0 equals negative 16t squared. Well, we have to know when it hits the ground to know what number to plug into the derivative. So we would plug in 0 for our height, because the height is going to be 0 when it hits the ground. And we'd have to find that time, and I'm going to let us use the graph instead of making us do quadratic formula for that. So you would have negative 0.235, but that doesn't make any sense in this particular context, so we throw it out. And then the other one is 3.985. And that is the time whenever it hits the ground. So that's what we want to use. Then we would plug that into the derivative. So h prime of, and we will use the calculator on this as well. Did they do this? Oh yeah, this stuff is straight out physics. And in fact, like, that class was algebra-based physics, so there were a lot of like formulas that they gave you. But if you're majoring in a math or science field, you're probably gonna have to take calculus-based physics whenever you go to college.
Honestly, that's probably better.
I loved physics. Like, I had the option of either taking chemistry 1 and 2 and physics 1, or I could take physics 1 and 2 and chemistry 1. I loved physics, but that's because I love math. Physics is just math. You do struggle with that. You do struggle with showing. Why is it negative? Because it's going down, and velocity has direction. So, since it's negative, that would be down. Speed does not have direction. So if it asked for speed, we would just say 67.52. So this could be used for something like if you knew that you were launching a pumpkin and it was going to hit somebody in the head and you wanted to know how fast it was going when it hit them in the head to see if it would knock them out or cause major brain damage. You know, you could calculate this experiment before you actually tried it. Yeah. It goes 70 feet in the air, so it's going to be going pretty fast by the time it comes back down. You have to multiply it by what? 3,600 over 5,280, or is it backwards? All right, let's not get caught up on it though. Okay, all right. So that one was not actually a transcendental function. I need to put it on the other notes. I need to work on my notes a little bit here. But okay, so you might want to put a box around this next one. Oh, is there already a box? Okay.
Oh, do we need to memorize that?
This is one you got to have memorized. He's still here. Okay, so if we're finding the derivative of 3 to the x, we're going to use this rule here. The a being just any number right here, a to the x is going to equal a to the x times natural log of a. So here, my derivative, I can either write y prime or another notation we're going to see sometimes. Sometimes you'll see this being dy dx. I'm just throwing that out there. It's another notation. It's not for y prime. Yeah, they're equal to each other. Same as f prime. Yeah. D over dx means take the derivative of this stuff. Yeah. Yeah, so d over dx means take the derivative of a to the x. And so if I've got 3 to the x, it's going to be 3 to the x natural log of 3. Yeah, that is our derivative. Yeah. And leave it, yeah.
Well, that's so easy. I was literally pulling out my calculator.
You just leave it.
I was like, all right, here we go.
It's just this formula. For example 5, we do have a 5 out here in front of our 1.2 to the x power. So it is just a coefficient that's going to stay there. Okay? We don't take the derivative of it. It's just a coefficient that stays there. And then we'll have 1.2 to the x power times natural log of 1.2. And this will be our f prime. I should label that there. You can leave it like this. Sometimes you'll see it like this, 5 natural log of 1.2. Whenever they're giving you f of x notation, it's pretty much always going to be f prime notation for the derivative. If they just give you a y, you can use y prime or you can use dy over dx.
Why can't you do 5 plus 1.2 x?
Because it is multiplied by the 1.2x to x, so you keep it being multiplied. So it's just using this formula. You just have to know the formula, right? So there's one that's even easier. The derivative of e to the x is super cool because it is e to the x. It is itself. If we think about our rule that we just had, our a to the x, our derivative of a to the x equals a to the x natural log of a. When I do e to the x, I'd get e to the x natural log of e. But natural log of e is 1. Because natural log and e cancel each other out. You just get 1. So you don't have to write the natural log of e because natural log of e equals 1. So the derivative of e to the x is e to the x. So it makes it super easy to take derivatives here. So for number 6, derivative of 3e to the x is 3e to the x. Don't do anything to it. Derivative of 4x is minus 4. So these are the easiest of derivatives, as long as you remember your rules. What is crazy about it, you don't know about antiderivatives and integrals yet, but if you did, its integral is also e to the x. So, yeah. It's pretty cool. I've got a video we need to watch about it sometime that I showed my pre-Calc class the other day, but they didn't really understand the last part of it, but you would. So, Euler's, it's spelled E-U-L-E-R, but I think it's pronounced Euler's. Yeah, it's Euler's, but it looks like it should not be. It is Euler's number, and it's super cool. So we might watch that another day. All right, now this one, because I've got that fraction, what should I do before I take my derivative? 6. And that is your derivative. So, does this make you think that you might survive? Yeah.
For another week? Yeah.
At least for another week, right? Till I bring back some limits or something. Yes. Very good question. F of x equals 6e to the negative x. We do not know how to do this yet. There is another rule we're going to have to use, so I'm not going to give that to you yet. We will learn how to do it, and it's not super complicated, but we're not there yet. So we can't do one that has anything besides just the x's as its variable right now. Okay? All right, logarithms. So, here's another one you need to have memorized. I will tell you that logs and things like 3 to the x, we don't do it very often in this class. E to the x and natural logs, we do a lot. So, our rule for taking the derivative of log with whatever base of x is going to be 1 over x times the natural log of whatever our base is. So if we need to take the derivative of log base 5 of x, then my derivative, I'm going to use a dy dx. You could use a y prime. Doesn't matter. It's just different notation for same thing. It's going to be 1 over x, and then my base is 5, so I'll have natural log of 5.
What happens if you have an actual number for that?
For the x, you will not see, just like the e to the x, you will not see anything yet where you have anything there except for an x. Yep, that's your answer. Derivative of g of x, g prime of x. The 6 is a coefficient. It just kind of hangs out front. We're going to have 1 over x, natural log of 4. I can write this as 6 over x, natural log of 4. Now, I am going to show you one thing they like to do on the AP test that is annoying, but they're going to do it. They might not leave it like this. All right, natural log of 4 could be written as natural log of 2 squared. Because properties of logs tell us what can we do with our exponent. Pull it out as a coefficient. 2 natural log of 2. So natural log of 4 is the same as 2 natural log of 2. And if we do that, 6 over x times 2 natural log of 2, now this 6 and this 2 can reduce 3, 1, because they like to torture young minds. Yeah. This would be calculator active. They would not expect, or not calculator, this would be multiple choice. They would not expect you to do it on free response, and don't even try it on free response because you'll mess it up. But a lot of times you might get this problem. And you got 6 over x natural log of 4, and you're like, this is easy. I know what I'm doing, but my answer's not there. And it is because 3 over x natural log of 2 is. Yeah. So it may just be helpful to tell yourself natural log of 4 equals 2 natural log of 2. So if you see a natural log of 4, multiple choice questions, a lot of times they break that down and simplify it. So that one's a little tricky. But if it's free response, you don't even have to do that. You can just leave it like this. The main reason they don't do it on free response is because it would be difficult to be consistent in grading if they did. Like, you might leave it one way and somebody else might leave it another way, and there might not be like one way that's necessarily more simple than the other. So they just say you don't have to simplify anything. But they do want you to be able to simplify. So they test that on the multiple choice section. So, all right, so natural log is very much the same. In fact, if we're doing the derivative of natural log, remember that's like log base e of x. So if I were using the other rule, I would do 1 over x natural log of e. But natural log of e, what does that equal? It's 1. So that means we just have 1 over x. Yes?
So natural log and logs are like pretty closely related. It's just really like a natural log just has like special cases.
Yes. And you can use the same. Yeah. They just have their own like their special rules are not really special rules. You could use the other rules. They're just easier, so we're simplifying them a little bit here. And you're more likely to see a natural log or an e on the test than having like a log base 5 of x. You don't see those as often, although they are occasionally on there. So if I've got 4 natural log of x, when I take that derivative, 4 just hangs out front. I got 1 over x. I could write that as 4 over x. So if I take the derivative for 11, I would get 6 over x. Oh, what would I might should have simplified that right here. This is x to the negative 2. So that'd be plus 2x to the negative 3. Okay, so 1 over x squared, I cannot take the derivative of it like it is, so I made it x to the negative 2. So we're pretending like I'm erasing that and putting this here. And then I'm just using power rule, so negative 2 times the negative that's already here is positive 2. X to the subtract 1 from your exponent, you get negative 3. Let me write 6 natural log of x minus x to the negative 2. So you're just using power rule. You multiply out front, that gives you positive 2. Subtract 1 from your exponent. Negative 2 minus 1 is negative 3. Yeah, the negatives out here cancel, yeah. Yeah. Now, for response, perfectly fine to leave it here. Here's what they might do on a multiple choice question. Common denominators. 6x squared plus 2 over x to the third. And the textbook will do this some too, so when you're checking your answers for tonight. We need common denominators to write that all together. So there's already 1x here, it needs 2 more. So you just multiply by x squared on top and bottom. So again, it's fine to leave it like this right here, but when you get to the multiple choice section or when you're checking your answers in the back of the book, it might look like this. Okay, questions? All right, let's do a couple tangent line problems, and then we will be done. Yes. Okay. All right, so write the equation of the line tangent to the graph of f of x equals 4 minus natural log of x at x equals 1. So we need 3 things for tangent lines. Point, slope, equation. Thomas, how do we find the point? Okay. Okay. Natural log of 1. Natural log of 1 equals, I don't know, I'm going to put an x right here. Okay? All right, so e to the power on both sides. 1 equals e to the x. What does that x have to be for you to get 1? Not e. 0. 0. So this is really just 4 minus 0. So let's think about it again. So my question, right, is what is the natural log of 1? So I want to know natural log of 1 equals what? I don't know. I'm going to put an x here. So to undo a natural log, we're going to do e to the power on both sides. And natural log of 1 will always be 0. And so 1 will equal e to the x power. So then we can think about what number would I have to put there for my x that would give me 1. And the only exponent I could put there that would give me 1 would be 0. So my x is 0. So natural log of 1 equals 0. If that confuses you, I like to walk through that because I have a hard time remembering what it is, and I have to think through it logically. If you're better at memorizing than you are walking through it logically, please memorize natural log of 1 equals 0, right? Because it will always equal 0. So we just get 4 for this. So my point is 1, 4. We all right on the point? Okay, so point we always have to have. What's the other thing we got to have? Slope, which we get from the derivative. Erase this over here so I've got room. So derivative Then how do I find the slope at this specific point where x equals 1? F prime of 1, and I'm going to label it, even if my name is Daniel Bautista and I'm too cool to label things. Alright, so we get 3. 3 is what we just said? Slope. Slope. Right, which we found by the derivative. So our equation is going to be y equals 3 times x minus 1 plus 4. So every tangent line you're going to do is going to be a point, a slope, and then the equation. For the point, we use the original function. For the slope, we use the derivative. And then the equation, we just plug in. For the equation, we're just using that point.
I thought it was just the y-intercept equation. Yeah, that's the equation.
That's what we're plugging into.
Yeah, that's what I thought.
Yeah.
I thought you were saying some other equation that was already
No.
there.
We're just plugging our numbers that we got into that equation.
The y whatever equation.
Yeah. All right, 13. It's a little more difficult for a few reasons. Occasionally they like to do this to you. So the line y equals mx plus b is tangent to the graph of g equals 3e to the x plus 2 at x equals 2. What are the values of m and b? Okay, here's the problem with this. It's not calculator active. So it's the same process. So to find that point, Eli, what have we got to do to find the point? Eli, plug into the equation. So g of 2, and we're going to label it g of 2 equals 3e to the second plus 2. There are certain people in this class that have a hard time labeling their work. And I'm hoping by harassing Daniel for his lack of labeling, it will remind all of you to not be like Daniel and label your work. I'm starting to realize that no matter how much I say it, Daniel's still not going to do it. Alright, so my point, here's the problem. I don't have a calculator. 3e squared plus 2, I don't know how to do. So my point has to be 2 for my x coordinate. 3e squared plus 2 is the y coordinate. So that's our point. If it was calculator active, we could type it in the calculator and get a decimal for it, but it's not. And it probably won't be if it shows up on the exam. Alright, so for our slope. For our slope, Thomas, what do we got to find for our slope? Derivative. So, Thomas, what is g prime of x? Very good. No 2 because it just goes away, right? So, to find our slope, we are going to plug 2 into this. So, it's 3e to the second. Once again, we don't have a calculator, so our slope has to equal 3e squared. Okay? Yes.
For the equation, that's the next. You do y equals 3e. Yeah, 3e squared times x minus 2. 2 plus 3e squared plus.
Okay. All right, so if it just asks for the tangent line, we'd stop here. But it says the line y equals mx plus b is tangent to the graph. It asks us for m and b. It wants the slope and the y-intercept of this line. So to do this, we are going to distribute that 3e to the x. B is your y-intercept. So we got 3e squared times x minus 6e squared plus 3e squared plus 2. Have I got anything there that I can combine?
6 and 3e squared.
Yes. That is e to the seconds I can put together. So I got 3e squared x minus 3e squared plus 2. M is slope, so that is the number in front of our x. It is. So m is 3e squared. And I didn't really necessarily have to distribute to know that. But to find b, I had to get it in y equals mx plus b form. So b is all this stuff over here. So b equals negative 3e squared plus 2. That's a number. We could type it into the calculator. It would give us a decimal for it. All right? Because it doesn't have any variables in it. E is not a variable. It's a number. So m would be 3e squared, and b would be negative 3e squared plus 2. These problems, they aggravate me. I do not like having problems that have all this stuff in your answer, but AP apparently does like to give those problems. So, I mean, they're good. They make you think about things. So. All right, so on yours, you guys did 19 and 21 last night, so I've changed it to 22 to 24. I think it's different on your page there. So you got 22 through 24, 35 through 38, 49 through 52. And then it doesn't have a lot of them that have bases other than e or for the natural log, for the logs and the exponentials. So I want you to do these 5 problems that are on those last 2 slides as well. Because our textbook did not really give those problems. Okay, what is due tomorrow? Test corrections. Also tomorrow, we are going to have a quiz on power rule. Does it have trig on it? Let me look at it. Let me look at it really quickly and see what I put on it. Let's see. All right.
Yeah, I need to take a picture of that homework thing just to make sure that I do the right thing.
Let's see. I need to do. I need to change the. Oh wait, that's not. Oh, it's not showing up at all because you got. How do I look at this? I don't think tomorrow has any trig on it. Oh wait, maybe I put one down here. Let me see. Yeah, it's gonna have some trig. But they'll be real basic trig like you had yesterday. And it'll have an e to the x, but it'll be real basic.